Good enough. Is everyone is good? I hope you understood like know what is exactly the distributions and all, right? Distribution in the sense we can how the spread how the data is spreading that we can see with help of distributions. So there we do have various kind of different kind of distributions are there. Let's see one after one, and the most famous things we'll discuss first, and then after we'll try to cover the inferential statistics. Abba, ah, oh, oh. Wait, it's taking too much money. Oh, oh. Start reading, guys. Probability distributions. Okay. So you already know about what exactly the distribution, the data, if how data is spreading or the data spreading, we can simply call it as the distributions. And we do have various distributions are there. The first one is uniform distribution. Uniform distribution means, and the data what we have it, that all data it could be equally spreading or equally distributed. Okay, all outcomes are e equally likely actually. Okay, second one is normal distribution. So normal distribution. So we'll see everything in a graphically so that we can easily understood. So the normal distribution simply we can say that it's a bell curve. Okay. So it could be follow the empirical formula like one standard deviation data, two standard deviation data, something like this. Most of the data it could be no two standard deviation itself. Okay. And Bayes theorem. Okay, let's see these two distributions, uniform distribution and normal distribution. And in generally, ideally, the data it was normal distribution, but actually in real time, data is not normally distributed. But if the data is normally distributed, that means we can easily get the results, and it could be the good to implement the machine learning models and all. Okay. Yep. So let's see uniform distribution and normal distribution. Practically, yeah, well, let's open. right? Let's see. Yes, is our last things. Are you practicing or not? These are all. Hello, hello. So whatever I
Yes, I can
explained
hear
so
you.
far, have you practicing or not? That's what my question.
Yeah, we are practicing. Like I'm practicing it.
Okay. So let's go for let's go for understanding the uniform distribution. For that one, definitely you should have a data. I'm considering that I can able to create my own random data as well. But in real time, data you might have a realistic data, but this particular situation I'm going to be creating my own data for it. Okay, I plot as a PLT and for example, for creating the data, we do have a random module is there in NumPy. And for creating that uniform data, so I have a function uniform. So with help of this particular function, I'm going to be creating the uniform data between 0 to 1 and with 1,000 samples. Okay. So I'm going to be creating the 1,000 data points from in between 0 to 1. Okay. So you can randomly selected the data between 0 to 1. It might be points in no, 0 points or 0 0.7 or 0 point something like that actually. Okay. So that is my data. So I have created some uniform data. I have created this uniform data. Like with help of the east method, with help of this method in matplotlib also we can able to see that how the data is spreading even in a seaborn also we can do it actually. So with help of bins, like there could be 10 bins for each, and so density equal to for example true. So let's go with TATLE plot title. This is uniform distribution, right? This is uniform distribution. Just I'm for showing you I'm creating this data, guys. Okay, and every time it's not the same. And let's have it like show method so that we can see that see if we see this particular, if you see this kind of distributions, whenever you distribute the data, if we see this particular graph, okay, that it could be the uniform distribution. See 0.0.02, 0.04, 0.4, something like that, right? See the data, whatever the data you have it, it was distributed equally. Hmm? Clear, right? Normal distribution means you will get the data in a you will get the graph in a bell curve actually. Okay, most of the values or cluster around the mean, that is exactly the normal distribution. For let's try that one also. Spicy is a one method for doing some kind of scientific operations and all. So this is the stats module, and we are going to importing the norms means normal distribution or normal data. Okay, if spicy is not there, that's your responsibility, like you have to be imported. Okay, so we have a random method is there for randomly for selecting, and here we have a normal method is there. So with help of this one we can generate the data normally, normal distribution. Okay, so that means most of the data it could be around the mean itself, but here the whole data it was spread equally. Okay, so I have created the data, and now I would like to go with plot. It is the method for histogram, and so that we can distribute the data. And so here we have a bins. So totally we can take the 10 or 30, it's up to you. So density it could be the zero, oh sorry, some value true.
Yeah, yeah. Here, Ranjan, bins means 10 times, 30 times repeating or what? Bins 10, bins 30.
So the bins in any plot. So generally what it will do, uh, how could I say? Yeah. So for example, when you are creating in histograms and all, okay, so might be you might have a data some kind of intervals, right? Okay, that intervals data we can call it as the bins. Okay, so for example, if you know um, it's just simply representing some kind of a range of values. um, you know and meanwhile, you might have a data points, and most of the data it could be false, no, each bin actually. Okay, so it's just simply intervals, 0 to 5 or 5 to 6 or 7. If it is the 10, then I have given, like, 0 to 1 is my data, right? Between the 0 to 1 only, right? So I have given a previously bin is the 10. That means 10, 10 equally 10 points on, uh, we will get it actually. 10 equal intervals, we will get it out. Right? Okay.
Yeah, understood.
Okay, let's go with this particular thing. What it is? Normal distribution, right? Okay. Okay, it's a 0 to 1 and 1,000 and the true. Density is the true. And this these are just all arguments. If you not understood, we can simply Google it and you will get it out at. Okay. What is the meaning of it at all? Okay. But whenever you're doing this kind of stuff, make sure that you have to be if you use this kind of arguments and inputs to your functions, then that's how we can able to get it the good visualization and all. Okay. X limit, and now we what we can take it as, like, you might have line space, like for this one we can see that, mm, line and all, and space x minimum, x max 100. Okay, and next the probabilities also, you can take it to probability distribution function PDF. It's a probability distribution function from your x, and probability distribution values are between 0 to 1 only. Okay. Next we'll do plot. Plot is the function for display your data. And a and line width equal to width is 2, and the title, it's a normal distribution. Next we can simply show off it. Okay, so here the spicy is not there, so that's a thing, and or else you might need to be use import method. Okay, pk is we should give it in a single quote, no model space, right? So we can how to install numpy, so the numpy pip install, that you can able to install. Okay. See, you, this is actually your data. Okay. So, mean is your zero actually. Okay. So so this is our, no, most of the data it was between -3 to +3. And so here 0 is your mean value. Okay. So see, whatever the data we have it, that actually it's a normal distribution in the sense it could be, you will be getting this kind of curve, but we can apply the standard normal distribution. When you're applying the standard normal distribution, so most of the data it was compressing between -3 to +3, and the mean it could be zero actually. Okay, so standard deviation is the one, and the mean is the zero. So here you might see that 0 comma 1, right? If the 0 indicating that it's a mean, and 1 indicating that it's a standard deviation. Okay, for example, if it is 10 is your mean value, and the standard deviation, for example, 2, and so that particular situation, see, uh, you are getting that normal distribution curve only. But see, your mean is 10, right? It's a middle value. Okay, that's how. That's about like this kind of stuff. Now let's talk about Bayes theorem. Bayes theorem, it could help you for whenever we start understanding that Navi-based classifier in machine learning. That particular situation will try to understand the Bayes theorem. Okay, in generally Bayes theorem, what is the use of it? It could help you for when you're updating that probabilities, and it automatically updating that probabilities. And if you're getting any kind of new things or new evidences, and automatically your probabilities, it could be updated actually. So this particular Bayes theorem will definitely learn when I started the Navi based classifier and all. Okay, so inferential statistics, let's talk about very important topic, which is inferential statistics. Yeah. Okay, now let's go for the new module, and which is inferential statistics. So far we are understood only descriptive statistics, right? Now we'll talk about inferential statistics. And coming to the inferential statistics, you're already aware of it. With help of inferential statistics, when we can make the decision, right? We can do the. It could help you for to make the a prediction. It could help you to make these some kind of predictions. And the meanwhile, whatever the visualizations, so we seen it previously. So with help of that one, we can draw the conclusions as well. Okay, we can do the conclusions as well. Okay, about your population or a sample kind of a stuff. Okay, now when we are talking about inferential statistics, we might need to be aware of it, a population, right? So you already know that what exactly the a population and all. So population means the whole data we are considering it. Sample means it's a subset of your data at times itself. And you know that this particular terms, right? Statistics means we're talking about the characteristics of a sample. And parameter means what? Parameter means we're talking about a population kind of a stuff. That's exactly we can call it as the uh, different kind of terminologies. But when you're talking about sampling inferential statistics, we might need to know about a sampling technique. So sampling technique means what? Sampling algorithms, like sampling technique. So whatever the population you have it from the population, you have to take some kind of sample data. For that one, we have various methods are there. So let's see those methods as well. Okay. So why samples? Why samples? First of all, you might have a population data, right? Why samples? So why samples? Why not, full samples under? Why not a population? So can you tell me what is the use of samples? So with help, when you are considering that, samples, then we can save the time as well. And so you don't need to maintain large amount of cloud storages or databases, because it's a very small amount of data we are considering it, and we are able to take the, or we are going to be inferencing the population based upon the small amount of data, so that in terms of cost is also effective as well. And often impossible, it might be it might be very tough to study the entire population. So that's the reason we can go ahead with the sample kind of stuff. Okay, so instead of considering the whole data, and if you want to study each and every data point inside of the population, so definitely it's impossible actually. Okay, so that's the reason we can go ahead with the sample kind of stuff. Okay, so when we are for example, this is my sample data, sorry, this is my population data. From my population data, I want to take the only some portion of data. Okay, that we can call it as the sample data. Okay, so how we can take it only this data? Why not this particular? Why not this one? Why not this one? Why not this the area? Okay, so for selecting the sample data from the population, there we do have various sampling techniques are there. The first technique is random sampling. Random sampling. So random sampling, what it will do, in a population, this is my population. There are various data points are there. Okay. So, and every element has equal chance to, um, every element have the equal chance of getting us into the sample. Okay. See, this is the data point, what we have it, and this data point, what we have it, both having the same priority. Okay, same priority, same chance to getting into a sample. Okay, there is no specific rule for it. For example, if you have the 1,000 data points, okay, if you have the 1,000 data points in your population, and from the 1,000 data points, I want to take only 100 samples. That particular situation, each and every data point, there might be chance of 1/10th chance to getting into the sample. Okay, equal chance to each and every data points in your population. That particular technique, we can call it as the random sampling. Clear? The second one is second kind of stratified stratified sampling. Stratified sample. And next one is systematic sample. Systematic sample. Let's talk about systematic sample. Okay. For example, we have various data points. Okay. So every kth element, for example, or else nth element. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have this kind of stuff. and I want to be take it systematic elements. Every fourth element I want to be considered. So this element and this element and 10th and or 9th or 13th, something like that. Every kth element we are going to be considering as the population, sorry, sample. Okay. For example, if you have the 1,000 elements, out of the 1,000 elements, and I want to take it the 10 elements, then you are giving some kind of a system for that. You have to take it every fifth element or 10th element or 100 element. That's how we can able to do it actually. Okay. So we have one more kind of sampling technique is there, that which is, it could be cluster sampling. See, in case of cluster sampling and in case of stratify sampling, approximately it could be the same actually. And whatever the population we have it, whatever the population we have it, so there we are dividing your population into different groups. This is one group, this is one group, this is one group, and this is one group. And then we are taking the sample from this particular groups. Okay. So, from this one, we can take some sample data. We can take some data points. From this particular group, we can take some sample points. From this particular group, we can take some sample. From this particular group, we can take some samples. From this, see, this is my population data. This population data, we are dividing into different groups. And from each group, we are taking some samples. And finally, we can combine this all samples as a one particular main sample actually. This is stratified sampling. Okay. Cluster sampling means we are dividing into your clusters, then we can take some cluster sample clusters. So either you can take this group, or if you have the 1,000 samples are there, or 1,000 groups are there in your population, after that one we are taking only some few groups. We are giving only priority for some groups only. Okay. So this kind of techniques we can apply for taking that sample from the population kind of stuff. Okay, clear, right? Let's see this all things practically. So that's how we can learn. Let's share my screen with, okay, so now we are talking about this one, right? Inferential statistics, right? Okay. I would like to import my pandas as my PD. As PD. And so I should have a data. So the data is, it could be a cluster, it could be a dictionary. So I do have a customer data, customer ID, and I'm going to be creating that, range of 1 to 11. That means 10 customers I'm going to be considering it. And second one is age of that 10 customers. This is age. And so 20, 23, 45, and 35, 33. Okay, 26, 29. Okay, 40, and 32, and 38, and 30. So these are my ages of this 10 customers. And next, income of those guys actually. Okay, income of those 10 customers. And for example, one customer, he is getting 50,000. And so second customer, it was 64,000. Tell me guys, you can give your own points as well. 58,000, 72,000, 48,000, 52,000, and 60,000, 54,000. How many? 62,000. How many data points are here? 10 data points,
10.
right? Yeah.
10 data points.
So this is my data actually. So this particular data, whatever I have it, that I would like to be go for converting into the data frame. For that one, we do have a data frame function is there. So data, we can provide it. It could be converted as the data frame. We can simply display also. So this is my data frame. Even if you read CSV files or Excel files, you can see this kind of is kind of thing only. Okay. Mhm. Let's take, you would like to take it some kind of sample data, and so df dot sample is there. So I would like to be considered the sample data. Okay, sample of n equal to 4. We are taking that 4 samples, and random state equal to 1, indicating that every time you will get the same data points. If you change that random state is different value, again our samples logic will be changed. Clear? Name sample is not there. Df dot sample. See, you're taking only 4 samples over here. Is it clear? So you're applying that, if you run one more time, you will get the same thing. Because random state we are giving 1. If I'm changing like on a random state is not 1, it might be different value. Let's take 5, then this particular situation we are getting the different values again, right? Is it same? Previously, same logic you're running 2 times. Okay, we are getting the same samples, but if I change the random state is different value, your samples was changed. Okay, is it clear? So this is how the sampling kind of stuff is there. So you can try with the stratified sample and systematic sampling and clustering samples as well. Okay. Now, a very important thing, central limit theorem. It's interview question, guys. CLT, central limit theorem. Central limit theorem. So this central limit theorem doesn't. It is also help you for um, sampling distribution only. Okay, no matter what is your population distribution. Okay, how your how your the population will be looks like. Okay, no matter your population. This is your first point. You need to remember it. No matter what is your population distribution, but the sampling but the sampling but the sampling distribution is after after you get the sample data, so that particular distribution of the sample mean is so we can find the mean of that particular sample. Okay, tends to tends to be a normal if sample size is the sample size is what? large large enough large enough and make sure that your sample size, it could be more than or equal to 30. Okay, see here, very simple kind of stuff, guys. Might be you have a population data. The population data, it could be very large. So because of that one, what happens in some situation, the data, it was not normal distribution. Whether it might be a normal distribution also, your population, it might be a normal distribution or might not be a normal distribution. You already know that what is exactly normal distribution. It's something like bell curve. Okay, if your distribution it might be a bell curve, it might not be a bell curve. But if you applied the if if you did the sampling kind of stuff, then we'll get some kind of sample data, right? That particular sample data, it must be or it could be a normal distribution. That is exactly the central limit theorem is stating that. Okay, is it clear? Okay, so how we can do it? Let's see that um first we need to import our numpy as np, and next we need to import your matplotlib. Import plot lib dot py plot as a plt. And so we would like to take the means of your samples. Okay. So sampling distribution of the sample mean. So it's how it is meaning is that I can tell you guys, you might be confused about this thing. Don't worry. Mm, okay. So this is your population. Let me consider this is your population. Okay. So from this particular samplation, you did one experiment and we are taking some sample. Okay. For this is your sample one from your population. So from this particular sample, we are calculated the mean of it. Okay. I'm taking that x1 bar. And from the same population, we are taking one more sample that I can consider as the S2. And if I'm taking that mean of 2, mean of this particular S2, okay, okay. And again, you did the one more time you're taking the sample, okay. So this is your S3. And from here, we are calculating the mean of this particular thing. So this is how from the population we are taking the different samples. For each sample, we are calculating the mean of it. And if this particular means of, this, if you distribute this particular means, this means distribution, sample mean distribution. Simply, I can say these are the different samples from the population, right? For each sample mean, if you do the distribution, it could be the normal. It could be normal distribution. That is exactly central limit theorem is stating that. Is it clear? Is it clear or not? Okay. That's what that's what we'll see practically. You have I'm taking the different means into the one particular means list. I'm going to be repeating it. I'm going to be repeating or repeating it for taking that range of 100. That means I'm going to be taking the 1000 samples. So 1000 sample groups. For each sample, it have only some number of elements only. Okay, so for each time I'm taking the sample and from my income variable, and I'm taking only 5 samples because I have only 10 only, right? Out of the 10, I'm taking only 5 samples. N equal to a 5. We're taking only 5 samples from your income, and then replace it could be the true so that we can replace it. So this is how we are taking that sample. This is how we are taking the sample from your income attribute, and we are holding into the 5 data elements into the sample variable. Okay, and I'm going to be taking the mean of it. So this is one list, right? I'm going to be finding the mean of it. So means dot appends. So I'm have the means list is there. So here I'm going to be appending my sample mean. I have the sample, right? I'm going to be calculating the mean of it. I'm holding into the sample. I'm calculating the sample mean. Calculating the mean of this particular 5 samples, and that mean I'm holding into this particular list. Again, I'm going to be repeating it. So next time I may get some new samples, new 5 samples, and I'm going to be calculating the mean of it. That is how every time I'm calculating the mean of each sample, and I'm holding into the another variable. That variable name is means variable. Okay. If I if I plot this particular means, if I plot this particular means, make sure that it could be normal distribution. Make sure it could be normal distribution. If it is a follows that one, then it could be the central limit theorem is stating that actually. Otherwise, it's not following the central limit theorem. Okay. CTL, central limit theorem. CTL, sampling technique, sampling distribution. of the mean samples. Okay, like so plot X label, sample mean, and Y label is frequency. You can show off it. See, this is your sample mean. I hope you understood, guys. Any questions? So whether it is following the normal distribution or not. Okay. So this is the thing is CTL is stating that, and any question? Hello.
No, no, Anjan.
Yes. Did you get it or not? Sample central limit theorem. It's a very simple thing. Whatever the samples, whatever the multiple samples, or whatever the samples we are collecting from the population, and we are calculating the mean of each sample, and we are just plotting it, and it is following the normal distribution. That is the definition of the central limit theorem. Definitely, it could be follow the that particular strategy only. Okay. Yep. That's for today's session, guys, and let's continue the tomorrow session all as well. I can continue the confidence intervals and hypothesis testing. Okay. Tomorrow also we do have a session. I can try to cover the various hypothesis testing like one sample t-test and jet test, ANOVA test and chi-square test. These are the different statistical tests we'll see. Okay. And from Monday onwards, we'll start the regression kind of stuff. That means we can say it's a machine learning part, Yeah. Yeah. That's for today's session. Thanks for your time. If you have any questions, I'm here to help you.
Thanks, Anju.
Okay.